Thank you for coming along, and hello to everybody joining us online as well. So this session is about reducing and decarbonising energy consumption. So we've heard quite a lot of advice over the course of the week about how to design a museum sustainably and a little bit about how to run a museum sustainably, but this is more about what you do several years down the line once all the architects and the engineers have gone. So it's a case study about our lived experience operating one of these systems, so it is a specific project, but a lot of what we've learned, we've been able to actually apply in lots of different ways to various other problems. So my aim today is to try and share that in a way that anyone can benefit from. We'll start with a quick description of the ship and why we do what we do with the ship, because it is a bit crazy. So the SS Great Britain was launched in 1843. She was the world's first iron ship. And she was also the first to be driven by a screw propeller, and this combination means that she was a huge technological milestone. Essentially, she was the first modern ocean liner. And her iron structure is quite significant because it was designed by the engineer Isambard Kingdom Brunel, who's a bit of a local hero in Bristol. But that structure allowed her to be bigger than had ever been possible before, so that's the significance of the ship. The structure also allowed her to survive being crashed and run aground on a beach right at the very beginning of her career. Now, this ordeal bankrupted the company that built the ship because they were forced to sell the ship for less money than she cost to salvage, but the ship survived. And the ship went on to become the fastest and most comfortable way to emigrate from Britain to Australia. Now, that same iron hull that I keep coming back to, allowed the ship to be refitted, reconfigured, repurposed, essentially recycled. How's that for embodied carbon? She sailed more than 1 million miles. She transported thousands of passengers before eventually she was abandoned in the Falkland Islands almost a century after her launch. In 1970, looking a bit different, the ship was salvaged and she was towed 8,000 miles back to the same Bristol dry dock that had been constructed in order to build the ship. So there's a little hint about the significance of the building as well as the ship. The historic combination of the ship and the dock, up until, unfortunately, about March 2020, has been almost continuously accessible to the public ever since the ship returned. Now, at first, the ship was cared for by traditional engineers using traditional ship maintenance methods, but this was wildly inappropriate. And the combination of Bristol's humid climate and the amount of salt that had become embedded in the iron meant that aggressive corrosion was putting material at risk of being completely lost. So in the 1990s, the ship got her first curator, who led the design of a world-first conservation system, which was focused on preserving the original material. Now, because of the higher salt concentration below the waterline, paint is no good, it doesn't work. Basically what happens is the iron continues to corrode underneath the paint, which all just flakes off, and then your process just starts again. So the only way to stop the lower vulnerable parts of the ship from completely disintegrating is to stop that corrosion chemical reaction. And to do this, we have to remove one of the elements. So we can either remove the oxygen or we can remove the water from around the metal. Now, we want to create a great visitor experience, so we should probably keep the oxygen. So instead, we conserve the hull by keeping it very, very dry. And the science tells us that 20% relative humidity should be our target. And that's about equivalent to the Arizona desert. Now, the system which does this, you won't be surprised to hear, is responsible for most of our organisation's carbon footprint. So this picture shows how it works. So we've got a glass roof over the dry dock, which is flooded with about 5 centimetres of water on top. So from the top, she looks ready to set sail out into Bristol. But underneath the glass, there are 2 custom-built desiccant dehumidifiers, and their job is to deliver dried air, one to the inside of the hull and one to the outside of the hull. And by doing that, we can keep the layer of air immediately next to the iron at 20% relative humidity. Now, we're an independent museum, and we rely on ticket sales to fund the running of this system. You can see why this is about to cause us a problem. However, we're an independent museum and we rely on ticket sales to run this system, so we put it on display. And part of the visitor experience at the SS Great Britain is to go underneath the ship and to actually see what your ticket money is being spent on. And this has been fairly successful, or at least people are, if it's not, then people are lying on TripAdvisor, but people seem to like it. And the environment around the ship using this method has been held more or less stable now for well over a decade. So to talk a bit more about the carbon footprint situation, the two main sources of carbon footprint in this system. First of all, you've got the fans which send the dried air on its journey around the ship. She's 100 metres long, so that's quite a long way that the air's got to travel to get to every nook and cranny. So those two fans account for about 50% of our entire organisation's electricity use. And secondly, the drying system, which I don't have time to explain in detail today, apart from to say that it uses gas burners for its heat. And this accounts for probably about 90% of our organisation's gas consumption. So we were told by the original designers when this system was built that it would always need to run on gas. Gas was the only suitable way of delivering this heat, quite simply because, firstly, the temperatures that needed to reach to remove this much moisture from the equipment, and secondly, the fast response time. So when it starts raining, fire up the gas burners, and we've got our humidity down nice and quick. The ship is safe. So I'll come back to that point a little bit later. Energy efficiency was considered during the original design, and there are various little bits and pieces and features in here that were designed to try and make the system as energy efficient as possible. But when the system was designed, nothing quite like it had ever been done before. So it only existed on paper and in some, by today's standards, quite basic computer simulations because it was designed in the 1990s. So my role was created in 2018, which is about 15 years after this system was commissioned. But once we had some real-life experience actually operating the system and some data to work from. And one of the things that I was asked to do was basically to figure out, could we do better? I've just been saying before the session that this has been quite an intense week for me because I'm not a museums person. I've never worked in a museum before. I started my first museum job when I started this job. However, I do have an engineering degree, and I've got some experience working with airflows, but I don't have any experience in building design or air conditioning. I've never been to any lectures on how to design an air conditioning system. So that meant I had no preconceptions about how an air conditioning system should work. So essentially what we were trying to do was to get a fresh pair of eyes on the problem. And what I found was that all of the individual components of this system were being really well maintained. We've got a fantastic team of site technicians, and we've got really good relationships with our contractors, which is great. But what my work allows us to do is to develop our own in-house understanding in the conservation team. I say the conservation team, I am the conservation team, of how the system as a whole operates in real life. And to identify what we like to call the unknown unknowns. So those are all of the opportunities that we didn't know that we had. Essentially the things that the designers couldn't have anticipated. So we had a computer which showed us that the average humidity in the space was mostly pretty close to the target. But when I dug a bit deeper, and this took a little bit of work, I'll explain why in a bit, into the software, I found two things. Firstly, that some of the sensors that were attached to the ship had not sent any data back to the computer for quite a long time. And the ones that were sending data were not sending data very often. So what that meant was that there was a long delay before any change in the external conditions was getting communicated back to the computer system which controlled this thing. And this is a problem because it causes the system to kind of overshoot and it runs too moist, too dry, too moist, too dry. And that's a very inefficient way to run. Secondly, once you opened up the dehumidifiers, they're completely modular, and what that means for anyone who doesn't know what that means, is that each component individually can be removed and replaced with something equivalent, and the whole system will still work exactly as it did before. Now that has been our superpower, because it's great in terms of making upgrades while keeping your embodied carbon from spiralling. However, so every one of these components had its own sensors attached to it. But the software for interrogating that data, actually I couldn't see any evidence that it had ever been used. It was not very user-friendly. It took me a long time to generate any kind of useful information out of it. So I went to our CEO and I said, right, we want to do some fundraising. I want to change the system. We're keeping the dehumidifiers as they are, but I want an up-to-date, modern, more user-friendly BMS, that's building management system, that's the computer. And secondly, I want some sensors that send me a signal more than every couple of hours. So we did some fundraising, and the theory was, we didn't quite know how, but if we could see what was going on a bit better, then we would be able to do some fine-tuning of the system, learn some stuff about the system, and save some energy. That was going to be the plan. So, now with my new toys, I can see the humidity live from anywhere on board the ship, and with this is the really game-changing bit, with my new, more user-friendly software, I can pretty much click on any component of the dehumidifiers and pull up instantly a graph of what's happening with that individual subcomponent today, this week, last month, so we can start to build up an understanding of exactly what the system is doing and what the subparts of the system are doing at any point in time. And I can also see, this is slightly less user-friendly, I can also now see the computer code which controls the system. And we've done a bit of careful experimentation, and we've had a lot of help from Wikipedia, but we've been able to understand how that algorithm works. And we've been able to start playing with it a little bit, making some small changes. And all of this new insight allowed us to start asking our maintenance contractors harder questions, more detailed questions, but we found that we were basically pushing against an open door. Actually, they were really pleased to be having more meaningful technical discussions with us about this system, because to the contractors, this is a really exciting system for them to be working on. And actually, we started working together. We started getting our contractors speaking to each other, which amazingly had not been happening before. And we started to make some small adjustments. But also, the fact that we were having these conversations meant that other kind of bigger opportunities started to come up. Now, firstly, one of our suppliers asked whether we would help them to make a case study video about upgrading one of the modular components of this system. So there are hundreds of these systems all over the world. Most of them are carefully hidden in rooms and cupboards behind the scenes, and nobody ever sees. But as a museum, we've got one that's actively on display. And so for our contractor, that was an opportunity. That was an opportunity to kind of get some publicity out there, to do a high-profile project. We got a discount. They helped us to calculate the energy savings, which I presented to our trustees, who said, yes, please. And the fact that we had that confidence and that we had that understanding of the system meant that I was able to confidently say, this is how long it's going to take for this piece of kit to pay for itself. And that was measured in months, not years. So I've got a photo of this. Sorry, I've got myself a bit out of order. So this is a picture that actually one of the local newspapers took of the kit arriving prior to being installed on the ship. So secondly, we looked kind of around and spoke to some of our peers around the city. Our local authority offers a green business grant fund, which is designed to help small businesses to reduce their carbon footprint. So we applied for some funding from that. And the local authority sent a technical advisor to do a site survey, and the idea was that they would survey our site, and then they would tell us what they recommended that we should install to reduce our carbon footprint. And the report came back saying that we should install better insulation and we should install LED light bulbs, and that was going to reduce our emissions by about 7.5 tonnes of CO2 per year. But with our new expertise, instead we were able to go back to them and say, actually, there's this energy recovery system that we're looking at, we've been offered. It's not on your list of suggested improvements, But if I can explain to you how it works, would you agree to fund it? And they did. So that was going to be installed with a predicted saving of 100 tonnes of CO2 per year. And so there's a picture of that here. So it's not a very sexy piece of kit, although we did install a green light just to show our visitors how green this system is. But it does really amazing things. Essentially, we've already got a heat recovery system. That's kind of a basic thing that you install anytime you're using hot air and discharging it. But this actually takes heat from the desiccant itself, which is like another round of heat recovery, and it's got multiple layers of why it helps improve efficiency outside of the scope of this talk. However, when we combine all of these things together, we start to get some really interesting results. So the system as a whole, both gas and electricity, are now about 20 to 25% less than before the upgrades. And some of the individual results are actually even better. So the larger of the two dehumidifiers, in the first half of this year, it burned 40% less gas than during the equivalent period last year. Now, earlier on, I said I would come back to something about temperatures. So we were told this system would need to run on gas because of the high temperatures needed to recharge the desiccant. But now that we've got our energy recovery system and we've smoothed out all of the overshoots in the control algorithms, we're actually now running at a much lower temperature. So you can see from this graph here, I'm an engineer, I like to do graphs, sorry, the next few slides are graphs. We installed this system in the middle of October 2021, and we changed the control algorithms at about the same time. And you can see before the upgrade, we've got the temperature required jumping around all over the place. But essentially, the system needed to provide us pretty much 100 degrees C. But afterwards, first of all, you've got kind of smaller jumps around. There's still room for improvement there. And secondly, the temperature that we need most of the time is actually much lower. So at this point, I got quite excited, and I had a small amount of money to spend on a consultant, and I sent them this data, and I said, can we now get a heat pump? Have we cracked it? And what I got back was really interesting. Essentially, they said, well, yeah, okay. But they recommended us a specialist heat pump, which can reach higher temperatures than a conventional one. And I looked at the numbers they were quoting, and what they had done was this. So they'd spec'd us a heat pump to meet the highest temperature that we would ever need for this system. But this is essentially just a more zoomed-in version of the after half of the previous slide. But our system doesn't actually need those temperatures very often. So what if, instead of asking, can we design a system that can meet our most demanding need, actually, for the sake of the climate emergency, can we just live with that occasionally? Can we live with something a bit less? So can we either find a way to stop the temperature spikes and kind of live with a lower temperature, or actually, can we just subject the metal to a slightly higher humidity for a very short period of time occasionally? And what I would like to do next is to commission some research to figure out what the answer is to that question. So there is some really good work going on around challenging what set points need to be, and we've got a branch of that as well. Obviously, it's in our interest to figure that out. But for us, this is part of a multi-pronged approach. To even get to this position in the first place, we had to get to know our system. We had to develop that understanding of how the system works, what's inside that black box, and how each component affected all of the other things that was going on. So at this point, for the last couple of minutes, I'm just going to move away from the specifics of our case study and share some more general things that we've learned that have kind of helped me to get through the last few years and get to this point. So firstly, people talk about maintaining a set point and saving energy as though they are two competing priorities. So I want to make it really clear that the work we've done to better understand the behaviour of this system has improved both the performance and the energy efficiency. So we are meeting our set point more often than we were before, and we are using less energy. So I think that talking about work to revise set points is really important, but I think it needs to be combined with better AHU, or better air handling literacy within, maybe even within the conservation profession, I think. I've talked really briefly about working with consultants and working with engineers. The thing I've taken away from that is that you can hire the best consultant in the world, and I'm not here to bash consultants, I used to be one, but the advice that you get from them will only ever be as good as the information you can give them to work from. And in the past, that is what had been our limiting factor. Our staff internally didn't know how to process this data, they didn't know how to access it, and so the consultants were essentially only seeing half the picture, and they were also only really getting short amounts of time to look at the data anyway, because obviously the cost constraint of hiring consultants. So we found that we can get much more familiar with the quirks of this system just because we operate it day in, day out. This is then. I am going to do some engineer bashing, but I can get away with that because I am one. If you're working with engineers or any kind of technical contractor, don't be afraid to ask them stupid questions. There is absolutely no such thing as a stupid question. If an engineer is speaking to you and you are their intended audience, but you don't understand what they're saying, it's not you that's the problem. Engineers are absolutely notorious for their use of jargon, and I'm on a personal mission to end that in my work, and you can help me out by not accepting it. So if you're struggling with that, I had a really good conversation with somebody earlier who told me that when her conservation team is struggling with that, she's the boss, she goes into the meeting, and she knows that when she's going into the meeting, she's there to ask the stupid question on their behalf, so that the contractor knows that actually the CEO wants to know that as well. It's not just the little conservator in the corner. I would also go so far as to say that if an engineer can't explain something to you in a way that you understand, then there's a fairly good chance that they don't understand it either. And I've actually had some real eureka moments as a result of me trying to explain something to a non-technical person and then realising mid-sentence that actually there's something in there that I haven't quite got either and can go back and change things, and that's really made a big difference. So it's not easy, but it is worthwhile doing. So the second thing that has really helped us is networks and communities. Now, this amazing group of humans is the Bristol Climate Leaders Group, and they are a group set up from across the city, so all different sectors and all different backgrounds, and at the bottom you can see what they looked like when I first met them. So we've also been part of the Arts Council Julie's Bicycle Sustainable Practice Accelerator Programme. And these have been really helpful. So my advice around networks is don't think that you don't know enough or you're not doing enough to qualify for them. Everyone has to start somewhere, and they are full of people who would love to help you. Now, I do take slight issue with the fact that they've called this group the climate leaders, because I think there's this really unhelpful narrative about everybody needing to be a leader. And I think where the climate emergency is involved, there is absolutely nobody who has come up with a clever solution to address the climate emergency who would have any problem at all with everyone else copying their idea. Most people who work on this issue are really super passionate about it, and they would absolutely love to help you. So don't at any point think that you're not knowledgeable enough or not confident enough to join these groups outside of the museum sector. So via these networks, we've been able to access the expertise of a whole range of organisations, some with much bigger budgets and much more resources than us. So we've therefore been able to pinch all the work that they've spent lots of money on doing. I'm currently looking at copying a system from one of the hospitals in Bristol, maybe, as a way to get our heat source into our dehumidifiers. And probably the most important for me personally is the emotional support. Like, working on addressing the climate emergency can be very difficult. It can be a really emotional thing to do. And especially during the pandemic, there was a lot of time I found myself working on my own, and having these guys to talk to just really made the difference and kept me going. So I would absolutely recommend trying to find a group of people to tap into in that way. And within the citywide group, because we are a museum, we're an iconic part of the Bristol skyline, we're quite well known. Everybody's like, oh, SS Great Britain, that's cool, what do you guys do? And that's given us loads of publicity opportunities. So via this group, we've been on the news, we've had the Cabinet Office come and make a video about some of our dehumidifier upgrades, which was shown at the COP26 conference. And the momentum kind of builds from there. There's a bit of fake it till you make it here. By shouting about what we're doing before we figured out how to do it, this has actually helped to get us in touch with the people who can help. So I would definitely recommend doing that. At first, I was very scared about being called out and being accused of greenwashing, but you have to get over that, and you have to just kind of build that momentum. So at the moment, our longer-term plan is still developing, but at a high level, it looks like this. Firstly, we're adapting our systems to use as little energy as they possibly can. Secondly, we're looking at the parts of that system that run on fossil fuels, and we're looking at how we can decarbonise them. So we're currently exploring a potential collaboration with the district heat network. Now, if we can get some or maybe even most of the heat for the dehumidifiers from the district heat network, I think that would be a massive win in terms of collaboration. It's great for the embodied carbon thing. Somebody else is using it as well. We're sharing it with the community. Maybe it will work, maybe it won't, but that's currently the plan. And then any remaining unavoidable gas demand, at that point you can start looking at things like biogas or hydrogen or maybe even that dirty word offsetting. That's a problem for another day. So demand reduction isn't the only thing you need to do, but hopefully you're all on board now with it. It's a really vital part. Like whatever else you're doing, we must reduce our consumption. It's more relevant than ever currently, obviously because of the bill situation, but in our case, addressing our energy demand has literally made the difference for us between decarbonisation being a viable option in the future and not. So therefore, I would suggest everybody starts with that. My overarching conclusion, I think, I've already said some of this, sorry, is that anyone who runs any kind of environmental control, it's very likely that there are untapped opportunities to reduce your energy consumption simply by getting to know the system better. And often that's without spending any money on big changes or compromising on the set points. But getting to know the systems better will also help you identify what your bigger opportunities are. And at that point, you can start making bigger changes. And if you really don't know where to start, looking at, so setting aside the ship dry dock dehumidifier for a minute, we have got a more conventional archive and some more conventional museum spaces, which in some weather conditions actually maintain their conditions better when they are switched off than when they are switched on. So that would be a really useful experiment you could do if you've got no idea where to start. Just pick a time of day, get some sensors on the go, switch it off for a bit, and just see how long it takes before you actually need it back on again, and then you can go from there. Actually, just last week, I met up with a couple of colleagues, one of whom have said that one of their systems was broken down and they haven't bothered to replace it because they've realised that they're better off without it. And secondly, one who decided as an experiment to just turn down the airflow rate, which saved them a huge amount of energy and made absolutely no difference at all to the conditions within their exhibition space. So if you really don't know where to start, that would be my advice. But ultimately, it's about developing the courage to open up your black box and figure out what's inside. And I would love you to get in touch if there's anything that we can do to help. What I said earlier about everybody who's doing this would love people to copy them and would love to help. Thank you.